Today I will show you two simple but useful things regarding my little Raspberry Pi autogardener project. First, how to automate the moisture sensor so it reports moisture level automatically every 15 minutes. And then, secondly, how to quick fix a little accuracy issue with the moisture sensor. Hi, I'm Tomi Mester from data36.com, and this is the next episode of a series where I document a hobby project of mine called Growing Strawberries with a Raspberry Pi on Autopilot. If you are interested in how we got here, check out the previous episodes of the series, but for now, let's get into it. Okay, let's start with the automation part because that will be fairly simple. First, I will log back into my Raspberry Pi with the SSH command. I add my password. Cool. Just a quick note, this SSH plus command is just an extra command installed on my computer. You can use the simple SSH command instead of this one on your computer. For me, this helps automatically connect my Raspberry Pi to my Sublime text editor, which is already opened on the left side. So this is Sublime text. And this is the command line. And so I'm logged back in to my Raspberry Pi, and I will open in Sublime on the left side the script that I have written in the previous video, which was called, let me check, it was moisturetest.py. Okay, Sublime moisturetest.py. This is the script, pretty nice. And let's run the script. And just for fun, I put my moisture sensor into a glass of water, so it will report some moisture level. Let's run the script, python 3 moisturetest.py. Okay, it says 520, 532, 500. Okay, so as I said, we have two problems here. The first one is the spread in the moisture level. We will get back to that soon. The second one is that I don't want this script to be ran manually by myself. So what I want is an automation that will start this script, and right now it reports the moisture level every second. And instead of that, I want to report the moisture level in like every 15 minutes. But for that, first I need to change this script so it won't run in an infinite loop. Instead of that, I want to run this moisture_red and get_temp functions only once when I run the script. And I will do that first. Then I will show you how I make this fully automated and run in every 15 minutes. So first, because I don't want to mess up my original moisture_test script, I will make a copy of it. Copy moisture test pi, which is not pi but py, whatever, into moisture automation.py. And I will go ahead and open this moisture automation file in Sublime. This is pretty much the same thing, but I will edit this a little bit. Okay, as I said, I want to run this part only once. So the first thing that I will do is that I remove the while loop. I will remove the indentations, of course. And I can actually remove this time.sleep function as well. I won't need this. And let's save it. Save. I saved it. And let's run this new moisture automation script on the right side in the terminal. Python 3 moisture_automation.py. And it reported the temperature and the moisture level only once, as expected. It also says this is said by us in the previous video that watering is not needed for now. I will remove this part as well. I will put it back when it's needed, or should I just comment it out? No, I will completely remove it. Okay, save it, run it. Temperature, moisture level. Cool. Now, as I said, I can keep this script as is and run it in every 15 minutes from the command line. And for that, I will need a tool called crontab, which I can open with the crontab-e command. Since for me, and probably for you, this is the first time that I run this command, on my Pi, I have to pick a text editor, which for me will be mcedit, because I prefer that. For this one, I don't need Sublime, so I will choose to. Actually, if you mess this up accidentally, I will show this to you. You can, and you accidentally picked Nano or Vim or anything else, you can recalibrate this with the select editor command. Select editor, it will ask you again, and you can choose 2, so you can use mcedit. Now let's get back to crontab, crontab-e, and here you can set up automations. I've created a separate video about how to use crontab, so I won't go into that here and now. I will just show you what I will do in this specific case. First, I have to set when I want to run my script, and the automation for that would look something like this. This means that on every day, in every month, on every day of the week, in every hour, our script will run in every 15 minutes. And then I will have to specify the command, or in this case, the script that I want to run, and it's going to be the Python 3, it's the command itself, and the script will be moisture automation.py, the script that we have just created. Oh, and one more thing. In crontab, you will always have to add a new line after your automation. So this is going to be our automation. It will run our new moisture automation script in every 15 minutes. But in itself, it worth nothing, right? Because it's not enough to run this script. I will actually have to store these values when I run this script. And how would I do that? In this specific case, I would do something like this. So this means that the output of this command and this script won't be printed on the screen, but into a file, and let's call the file moisture data.txt. Let's create a txt file for now. We can tweak this data file further in the future, make it nicer, but for now it's going to be moisture data.txt. Cat moisture data.txt. There it is. If I run the script again, it will store the data again. So, oops, one issue. If you put one arrow, that will always overwrite this data file. So I will actually have to put here 2 arrows, which will add the output as a new line to this data file. So test that out and check the moisture data.txt file. Now it has 2 lines. And so actually, to have this automation correctly run and store this data into this moisture_data.txt file, I will have to update my automation in crontab as well. So instead of this, the full command will be something like this. And so if you took one of my courses ever, any data science courses I created, you know that I hate to add scripts or file names with a relative path, because that's where the scripts and automations fail. And so I have to actually add the full path name here, which you can get with the pwd command. And for me, these moisture_automation.py file and the moisture_data.txt file are located in the home/pi directory on my Pi. So I will go back to crontab again, and I will add the path here. Now this crontab automation looks properly set, so let's give it a try. Let's check out the date time right now. So in a little bit more than 5 minutes, in theory, a new line should be added to my moisture text. Sorry, it's moisture data.txt file. Right now it has 2 lines. And let me pause the recording right now, and I will get back to you in 5 minutes, and we will check out whether the new line is there or not. Okay, I'm back, and let's check out the date right now. We are 15 minutes after 5 p.m. In theory, a new line should show up in the moisture_data.txt file. And there it is, there is the third line. It says the moisture level is 519. Now I actually want to add one more thing to this line. And I go back to my moisture_automation.py script, and since we are building here the moisture data log of the moisture levels and temperatures, we will need the most important part of a log into this file as well, which is of course the datetime data. And for that, I will need to add the datetime function and first the module to my moisture_automation file. It's from datetime import datetime, and I will need here a new variable. What time is it? And let's call it date var. Not the best naming convention, but I can fix this later. So date var is datetime.now.iso format, and the separator will be a space. Before I save and run this, let me show you quickly in Python what I have done, what this will be, and I will show that to you in the command line. I cleared my screen and I will open Python 3. So I imported datetime from datetime import datetime, and I saved this output into a variable. So this is datetime now, the current time and date in a not too nice format, and with the ISO format function I can make this nicer. And the only thing that I don't like in this formatting is this little t between the time and the date, and I can replace this by adding an argument here, which is a space. And from this point on, in our script, this data will be saved into the date_var variable, which will be important because every time I run this little script, or actually when crontab will automatically run this script in every 15 minutes, the date and the time will be saved into our file. Or actually it won't, because I have to add this into the output of this file. Okay, you know what? I will do one more thing. I will just remove this temp and moisture text, because I already know that we are talking about temperature and moisture level. I don't need that in my data file. I save this. Just in case, I will do a test run in the command line. I closed Python on the command line, and let me run my updated moisture automation script. Good. It's the date, the time, the temperature, and the moisture level. And so in a few minutes, this will be saved to this moisture data.txt file. Or you know what? I can just simply run this script again and add this new line to the moisture data.txt file. Let's print the file. Okay, here it is. And since in the first 3 lines we haven't done this proper formatting and adding the date and the time, I will just remove the first 3 lines from this file. Or you know what, I will delete the whole file and I will start it from scratch. Here it is. I run the script again. And so my new moisture data.txt file will look something like this. Not the nicest format right now, but this is what we need for the time being. And just in case, check out whether our crontab automation adds a new line to this file. So I will pause the recording again and we'll start it again in like 3 minutes. Okay, I'm back and let's check out whether we have the new line in our file. Perfect, we have it. And we can also see that it was recorded 30 minutes after 5 p.m. just as it should have been. So in theory, from this point on, if I leave my Raspberry Pi turned on, it will run this moisture_automation.py every 15 minutes, and it will add a new line in every 15 minutes with the new data, with the new measured moisture level, temperature, and date time to this file. Cool. And we can move on to the next issue, which is the accuracy of our moisture level. And for that, I will clear my screen, close this moisture.automation script, and I will open the moisture test.py file in my Sublime Text again. And if I run this one, which you know measures the moisture level in every second, you will see that the moisture level changes every second, and it's, for me at least, it's quite a big spread. So I will stop this. So sometime we see 512, or we see 556, or we see 547, and so on. And as I said, currently, when I run this script, my moisture sensor is in a glass of water. And you know, the high school physics class was a very long time ago, but as far as I remember, the moisture level of water is, or should be, quite constant and stable. So this spread in the moisture levels for me shows that this moisture sensor that I use is not 100% accurate, but it's not an issue because we can actually average these values, and I will show you my approach with this. And I will test something simple for now, and I will move back to editing my moisture automation script, the one that we have just created for the automation. And my trick will be, well, it won't be that tricky. I will remove these comments. So the trick will be that instead of measuring the moisture level once when this automation runs, I want to measure these 5 times. So I will run a for loop and I will measure the moisture level 5 times, and I will leave 5 seconds between these. And so I have to tweak this a little bit. Actually, this touch value be the last step of this for loop, and this moisture read data will go into a list. Okay, so I will create a moisture list. Again, a bit lame naming convention, but it will work for now. So I will put this moisture read data into this moisture list with the append function. And with this, in the moisture list, we will have 5 data points that are sampled in 5 seconds after each other about our moisture level. And you guessed it, we will calculate the averages of these 5 data points, which can be done easily by summing the elements in our moisture list and then dividing it with the length of the moisture list, which will be 5, by the way, and this will be our new touch value. Now, I will run this, and I hope that it won't throw an error. Python 3 moisture automation.py. So far, so good. This will take 25 seconds, of course, because of the time.sleep part, so it will take a bit time. And there you go, there is our average, and I hope that this will lower the spread between the values, and I can test it if I run this script a few times. So you don't have to wait 25 seconds, I will speed the video up. Okay, so far so good. One more. Cool. Okay, I accept this as a good enough result. The spread is a bit lower. Of course, I will be able to evaluate this after 1 or 2 days when I check out this file where we will store all these values. And you know, in 1 or 2 days, I will see here like 100 plus lines. And if the spread is smaller than it was above, then I will be happy. And just in case, let me tell you that I have actually run this little experiment before I recorded this video. And so I can promise that this small averaging trick will do the job. And that also means that we are done with the 2 tasks that I set for myself today. Just to recap, the first one was to automate the measurement of the moisture level, and we have created this moisture automation script. From the script from the previous video, we put it into crontab, and so it runs in every 15 minutes. And the second one was fixing this moisture level accuracy issue, and for that we just took 5 samples instead of 1 sample to our moisture measurement, and we averaged it, and it fixed the accuracy issue. Of course, we can improve this further, but for now this will be good enough. Before I wrap this up, just a quick comment that every learning material that I mentioned in this video will be linked in the description, as well as the GitHub link of this script. So if you are not 100% sure what happened here, you can go to my GitHub, check out this script, test it for yourself, run parts of it separately next to my video, whatever. Point is, links are in the description. And this is the end of this episode. If you liked it, please subscribe, leave a like or a comment. And if you have done projects like this and you spot any mistakes I made, or you have best practices you want to share, please do not hesitate to share it in the comments. As of the next episode, I finally got both the plant lights, as you can see, and the water pump as well. So I will pick one of those topics and we'll continue with that. Anyways, don't forget to subscribe to my newsletter at data36.com/newsletter, because this is the only place where I really communicate to my audience right now. So this is where you can get notified about new content as well. And if you do subscribe, you will get access to a lot of free data science learning materials too, like a Python cheat sheet, an SQL cheat sheet, or a free mini course called How to Become a Data Scientist. Thank you for watching. I'm Tomi Mester from data36.com. See you in the next video.